Hey guys, this is Taylor here, and today we are solving problem number 3628, which is from weekly contest 460, and this is the second problem of the contest. So let's get started. So you are given a string S consisting of uppercase English letters. You are allowed to insert at most one uppercase English letter at any position. Okay. Now I need to return the maximum number of LCT subsequences that can be formed in the resulting string after at most one operation. A subsequence is non-empty string that can be derived from another string by deleting some or no characters without changing the order of the remaining characters. So let's quickly see what is given to us. So so if you know what is subsequence, well and good. Otherwise, let me tell you. So if we have some string like this, so what can be the possible subsequences of this? A can be one possible subsequence, B can be one possible subsequence, C, D. Okay. Now I can do something like this. I can pick A, B. Okay. Now another subsequence I can have is A and C. Okay. So this can also be a subsequence. Another subsequence I can have is A and D. This can be my one of the subsequence. Otherwise, I can pick B and C. I can pick B and D. So you can see that what is subsequence? Subsequence is basically I have to take elements in order. So I can take A or I can take any element from this. More than one, more than two, whatever. But only thing is we should the subsequence is always goes in order. So you can see if I write one subsequence is A, B, C, one another subsequence B, C, D. So all these are subsequences. So you can see order is maintained. A is coming before B. A is coming before B. B is coming before C. B is coming before C. B is coming before C. C is coming before D. So order is maintained, but we can skip any elements in between. So this is definition of subsequences. So we have to find how many subsequences in our string with this subsequence. How many subsequence? So we have, let's say, a very long string. So how many times we can find this LCT in our string? So it can be like there are some character X, Y, then C, then Y, then L, then T. Okay. So how many subsequence of LCT are there? So I can see one L here, then two C here, and one T here. So how many subsequence I can have? So I think this can be one subsequence and this can be another subsequence. So I can have two subsequences in this string. So I hope question is clear to you. What is subsequence and what we have to find. So in this question, the trickier part is how we will be calculating the number of subsequences. So this at most addition one uppercase letter and all this you will be able to figure out once you figure out how you will be able to calculate the number of subsequences, number of LCTs in the given string only. If you are able to calculate this now, then the answer will be very easy. We can see that. Okay, so let's go with the question what is given to us. So we have given, let's say, let's take this test case LCCT. Okay, first of all, let's quickly count how many subsequence we can have in this string. So here is my one L, here is my another C, here is my one other T. So this can be my subsequence. Okay, another subsequence I can have is this one. Okay, so total of two subsequences L, C, T. L, C, and T. Okay, so I'm having these two subsequences. I hope you got it. So how will we approach to solve this problem? So the intuition, the idea behind solving this problem is, so if you can see now, we have to calculate how many for this C. For this C, how many L's are in the left side? We have to calculate. And for this C, how many T are in the right side? So if I write with marker for this C, what matters to me? How many L's in the left side? If there is some C, there is T, there is M, there is N, there is O, P, whatever this string says, I don't care. I don't have any issue. I just bother about how many L's are there in the left string. And for this C, how many T are there in the right string? There are P, Q, M, N, L, whatever. I don't care. What I care is how many T's are there. So for any character, let's say LCCT. For any C, I just need to bother about how many L's are there in left part, how many T's are there in the right part. For this C as well, I need to bother about how many L's are there in the left part, how many T are there in the right part. Okay, so you might some of you might guessed it. This is kind of a prefix suffix kind of problem. If you have solved similar problem, well and good, you might have guessed it. So what we need to maintain? So we need to maintain at every point, how many at every point, at every index, how many L count are there and how many T counts are there. So this way you will be able to optimally solve this problem. So at each index, I will be keep tracking of my number of L's and my number of T's. Okay, so let's see what we'll be doing. So I will be writing something like this. Okay, now I can write my prefix. What my prefix is? So my prefix is basically count of L, and my suffix will be count of T, because at every point, I hope you got it, but at every point I need to bother about how many L are there in the left side, how many T's are there in the right side. Okay, so let's draw a prefix array quickly. So initially all elements will be initialized as 0, and in suffix as well I will be initializing all elements as 0. I'm not writing zeros here. Consider here zeros are there initially. Now I will start with the prefix array. I will check whether this is L. Yes, it is L. I can increment it. Whether this is L, no. I will keep it same. Whether this is L, no. I will keep it same. Whether this is L, no. I will keep it same. Okay. Now let's talk about suffix array. So I will go here. Whether this is T, yes, I will add one here. Whether this is T, no, I will keep the count same. I will keep the count same. I will keep the count same. Okay, let's take one more test case so that we understand it better. So let's take little long test case. We have something. Let's create. Okay, so here I have written one test case, and I will be calculating the prefix and suffix for this test case now. So let me quickly draw the prefix array. And the suffix array. 1 2 3 4 5 6 7 8 9 10 11. Super. So I have calculated, I have written my prefix and suffix array, and let's try to fill this value. So consider all values are initially initialized with 0. In all this prefix and suffix, all values are 0. Okay, let's start. Let's start filling the prefix. So I will be checking. Is this a L? No, this is not L. I will be keeping it 0. Is this a L? Yes, I will be making it 1. Is this a L? No, 1. Is this a L? Yes, it is L. I will increment. Is this a L? No, I'll keep the same. Is this a L? Yes, it is. I will increase. Is this a L? No, it is not. I will keep the same. Is this a L? No, same. L? No. L? No. L? No. L? No. Super. Now let's try to calculate the suffix. So let's quickly calculate the suffix as well. So I will start from here this time. And in suffix, what I need to track? I need to track T's, right? So is this a T? Yes, I got it. Okay. Is this a T? No, same. Is this a T? No, same. T? No. T? No. T? No. T? No. T? Yes. 2. Is this a T? No. T? No. T? No. T? No. Super. So I have calculated my suffix and prefix. Now let's see how we'll be doing the further calculation. So for this, I will be just cleaning it out little. Okay. So as we know, for any prefix and suffix, for any element, for any C, what I am worried about, I am worried about how many L's are there in the left side, how many T's are there in the right side. The right side of that, in the left side of that. Okay. So I will be doing the same thing. So as soon as I got C, I will do some operations. So let's take a green. Okay. Uh, my pen is not working. Okay, so I will be starting from here. Is this a C? No, it is not. So I will not do anything. Is this a C? Yeah, no, it is not. I will not do anything. Is this a C? Yes, it is a C. So I will be keep tracking. How many L's are there? I will be asking from the prefix array. How many L's are there in the left side? I will go here. It will tell me, okay, there is one L. So okay, I will write it here. Now I will be asking how many T's are there in the right side. I will be asking suffix array. How many T's are there? It will tell me there are two T's in the right side. Okay, I will write that. I will write. Okay, so this will give me the number of LCT pairs coming from this C. So it will give me 2. Superb. Now is this a C? No. C? No. C? No. C? Yes, it is a C. I will be asking from the prefix array how many L's are there in the left side. Okay, it will tell me 3. Let me write 3. Okay, I will be asking the suffix array how many T's are there in the right side. It will tell me only 1. Okay, this one, this one. So I will write the 1 here. Superb, 1. Now let me add it. So it's giving me 3. Okay, superb. Now let's go further. Now I will be asking this C how many L's are there in the left side? 3. Superb. How many T's are there? 1. Let me add it. Superb. I'm multiplying it here. Okay. Is this a C? No. C? No. C? Yes. So 3 into 1 again because 3 here, 1 here. Superb. Again we got 3. Now is this a C? No. It's not C. Now let's try to sum it up. 3, 9, 3, 6, 9, 10, 11. Okay. So 11 is the answer. 11 is the number of subsequences we can get from this string. Okay. So I hope you got it how we are calculating basically the subsequences using this string. Okay. Now our task is simple. Now what is given to us in the question? What we have to do? We have to basically add at most one uppercase letter, any English letter I can add, such that my LCT subsequence can be maximum. Okay. Now, if I think in very greedy way, and if I think in a very brute force way, okay. So whenever we start thinking, we have to think in very brute force way. That will definitely help us. So there are only three things that can help in increasing my answer. Okay, let's see what. First thing is adding L, C, or T. So either adding L somewhere, either adding C somewhere, either adding T somewhere. If I add M somewhere, will it contribute to my answer? No. If I add M here, will it contribute to my answer? No, it will not. If I add N here, will it contribute to answer? No. But if I add something like add T here, it can contribute to my answer. Yes. So the first observation is I should be adding either L, either C, either T somewhere in the string at least one time, at most one time. Then only I will be able to increase my answer. Now I need to find the optimal place for L and C and T. So let's see what is let me quickly write this string here. Let's work on this small string LCCT. I think that we will be able to easily understand. LCCT. Okay, so I have L here. Okay, let's make a plan. So my plan one is I will add L. Okay, this is my plan one. So if I optimally think and if I have to add L, where I can add? If I add L here, so how many L's? Like how many strings, how many LCT pairs are present here? That can be, I think, increased. Why? Because if let's say this contains 1 2, this is 1 and this is 2, so one pair is this, one pair is this. I was having two answers, but if I add one more L here, I can increase my answer by 2, right? So this can be one pair, this can be another pair. So my previous answer was 2 and my current answer increased by 2, it got doubled, I got 4. Okay, so if I saw this thing, so if I have to add na L, I will be adding it in very beginning. Okay, let's see about next test case. LLC, sorry, it should be L C C and T. Now let's say if I have to add T, okay, where should I add T? So if I add T in the last, I think all my substrings can be doubled again. Okay, let's see how. So this this was my first, this was my second. Okay, LCT pairs, LCT subsequences. Now if I added T here, what can be my another option? This can be my first option, this can be my second option. Again I got doubled answer, this got doubled, 4 I got, right? So if I have plan one, so that is fine, I will be adding in the leftmost side. Okay, now my plan two is I will add T. So here we saw if we add in the rightmost side, that will give me perfect answer. Okay, rightmost side. So if you have still doubt why we are adding L in the left side and T in the right side, let me know. So I hope you got it why we are adding L in the left side, because it will double our answer. Okay, now we have to find our let's next plan is plan 3, which is I will add C. Now I will be asking myself where should I add C here? So I will again write a string here. Now where should I add C? So I can either add C. Let's explore what places I can add C. If I add C here in the very beginning, will it contribute to my answer? No, it is not. If I add C here, L C C C, this is my added, okay, and T. Will it contribute to my answer? I think yeah, it is contributing to my answer somewhat, yes. If I added a second place, okay, L C C, this one is added and T. Is it contributing to my answer? Yes, somewhat yes. Okay, now let me try next place. So I think this one, will it contributing? Yes. And the last place, which is L C C T and C, will it contributing to my answer? I would say no, it is not, because that last element that I want in my subsequence, which is T, and if I add C here, and the first element that I want here is L, and if I add C in the beginning, these two options are not working. Okay, this is not contributing to answer. So one thing I'm sure that for C, I don't need to add in the beginning, I don't need to add in the back. I need to add it somewhere in the middle, somewhere in the middle. So where should I add it? Okay, so for that let's bring one test case, then I think we'll be able to understand properly. LCLPTTGC, LCLPTTGC. Okay, fine. Let me quickly draw a prefix and suffix array for this. Yeah, prefix, this is suffix. 1 2 3 4 5 6 7 2 3 4 5 6 7. Let me fill it off quickly. 1L, 1L, 2L, 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 0T, 0T, 1T, 2T, 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 2T. Okay. Now I have filled this prefix and suffix array. Now I have couple of options. So I will not be adding here. I will not be adding here. Okay, L will be adding here, T will be adding here, but C I won't be adding here. T I won't be adding here. I need to add either here, either here, either here, 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 here. I need to add one in one of the places. So where should I add? Let's try adding here. Okay, I will add here. So I will be making a C here. Okay. Now, what that C answers will look like? I think that C will take up of this value, right? This value. It can take this or this, anyone, no issue. So let me take this one. Okay. So how many L's are there in the left side? One L. How many T's are there in the right side? Two. It is giving me 1 into 2, which is 2. Okay, let me write it. So the if I add first index, it is giving me 1 into 2, it's 2. Okay, here if I add. Now let's try to add here. If I add here, I will be taking the left wala guy. Okay, so this guy is again telling me 1 into 2, which is 2. This part again. Okay, superb. Now if I add here, let's see what it is giving me. It is giving me 2 into 2. 2 into 2. Superb. So it's giving me something in better. If I add C here, so if I add C here, visualize it. Okay, if I add C here, how many L's are there in the left side? 2 L's. It's telling me 2 L's. How many T's are there in the right side? 2T. Why? 2t. Okay, super. So I was using blue color. Okay, now let's assume that we have not added c here, and I will try to add somewhere here. So if I added c here, I will go to the left side. I will ask what is the value. So it will again tell me 2 into 2. It's same. Super. I will try to add here 2 into 2 again, and I will get 4. I'll try to add here. It's this time it's telling 2 into 1. Okay, no issue. This time if I add here 2 into 0, it's 0. It's giving me 0. Okay. So if you can see, where should you add? If you want to find the maximum answer, you can either add here, here, or here. That means either you should add here, okay, either you should add here or here. Now carefully observe why we are adding here, because these two parts are giving us maximum answer, maximum answer. These three parts, na? Why we added here? Because so far we tried adding, but this part was giving us maximum answer. That's why we added here, right? I hope you got it. Okay, so this is the same intuition that we'll be using. Now let's quickly write some pseudo code. So what I will be doing? So one modification I will be doing. Okay, so I will make my prefix array like this. So if I have LCCT, so my prefix array will look like. Don't worry about it. Okay, why I'm doing this? I will let you know while we are coding, or maybe pseudo code time. So I will make one extra here. Okay, and my suffix array will look like something like this, and one extra here. Okay, so my prefix array length would be n plus 1, suffix array would be also n plus 1. Why I'm doing this, we will see in the calculation time. So initially all values will be 0, this value will be 0. Definitely I will be starting from here. Okay, and I'll be calculating 1 1 1 1, and for suffix as well, this value will be 0. I will be starting from here. I will be keeping it 1 1 1 1. Okay, so these values will help me. Let me tell you, these values will help me keeping track of the calculation while like without any if else conditions. Okay, let's write the code. We will understand it, what we are doing, why we are doing. So let me write a prefix array of 0, and I will be, the size should be n plus 1, and suffix also with zeros, and size should be n plus 1. Now I need to fill prefix array. Okay, so let's fill it. So my prefix array will be starting from the first index. You can see here, right? I'm starting from the first index. So let's see how we'll be filling. So for I equal to 0. So my strings will be starting from 0. So I will be keeping it 0 to n minus 1. N minus 1 is, n is string length. So I need to go till last index. So I will be going to n minus 1. Now if string of I equal to L, because I am just worried about L while filling prefix array. If it is L, what I need to do? I need to, I can keep it 1, right? I can mark a 1 here. So let me write it. So prefix of I equal to 1. Now the one more thing we were doing here. So we were adding 1 here, but you can see I added the last element as well. So how L was 2 here? Because one L was here and another L was here. So this that's why it became 2, right? So I will be doing same thing here. So my prefix array will take up prefix of I, so it should be I plus 1. Okay, I plus 1, because we are in the I plus 1 stage. Prefix array is looking like this, so I am in the I plus 1 stage. So my I plus 1, prefix of I plus 1 will be equal to prefix of I plus 1 plus prefix of I. Why I'm having this condition prefix I plus 1 here is that because so let's say when I am calculating this, I was adding this element, but if here nothing was present, so it will give me that some index error. That's why I have added extra dabba here, extra box here with 0. So that will help me do my calculations without any if else condition. With if else condition you can do without any extra box. Okay, so similarly we can calculate suffix fill suffix table, suffix array for I equal to n minus 1. Keep note of that to 0. Okay. If string of I, what I need to track here, I need to track t. If that is t, what I need to do, I need to add a what I need to add 1 here. Okay. And in the last, I will be adding suffix of I will be equal to suffix of I plus suffix of I plus 1. So because here we were keeping track of the elements from the last, I was adding here, I was adding here. If we say here it was 0, then it was 0, then we became 1, it became 2, then 2, then 2. I was adding the previous. Okay, that's why I'm having this conditioning. Now after filling prefix and suffix, what I need to do, I just need to check if that is C. I can have three conditions, right? Let's write three conditions. So first is plan one was add L in left side, leftmost side. Plan two was add T in rightmost side. Plan three was add C where prefix into suffix is maximum, right? We saw here. If you have any doubts in that part, let me know. So let's try to write pseudocode for this part. So what I will be doing, I will be treating from this for I in range n. Okay. Now I will be having my plan one, I am initializing with p1, plan two initializing with p2, and plan three I'm initializing with p3. Now what I need to check, if very easy, very easy, if s of I equal to c. Okay, equal to, if that is a C, that and then I need to do some operations. What I'm doing, so P1 equal to P1 plus, now what should I do? What should I do? So P1 is tracking L in the leftmost side, okay, and my prefix array looks like this. So let me write it here, LCCT, and my prefix array somewhat looks like this, 0 1 1 1 1. Now I'm here. Now I'm saying that I will be adding one L here. That's what my plan one is, right? I will be adding one L here. So what I need to do? I can I can increment all these values with 2, right? I can do that. So either I can do basically modify this array, or either I can write a plus 1 here. Okay. So let me do it little optimally. So I will write while accessing the values now, I will be just adding a plus 1 here. So prefix of I plus 1. Why I plus 1? Because if we are in the zeroth string, sorry, if we are in the zeroth string, we are accessing prefix I plus 1. This was our added. So our question looks like this. When we were here, we were accessing I plus 1 at the index. Oh, where it went. Okay. Now, while accessing prefix I plus 1, I will be adding a 1 plus 1 here. Okay. I will be little optimal here. So this was my plan 1. Now, what I need to do with after calculating this P1. So this P1 will look like this. Now, what I need to do? My answer will be, what will be my answer? If I will get some C here. What I need to do? I need to multiply this with this part, right? So let me do that. So my answer will be prefix of I plus 1. So whatever value I am getting here, multiply by here, suffix of I. And why I am writing suffix here? Because suffix array is in this place only. Okay, I hope you got it. So suffix of I. Now let's check for P2. What is P2? Let me write here. Okay, I am writing here. P2 equal to, what is plan to add T in the rightmost side. So in that part, what I need to do? So I will be incrementing my suffix of I, whatever I value is, I will be incrementing plus 1 here into prefix of I plus 1. Why I'm doing this? So for this test case, again, LCCT, this was my original case. Now I'm adding a T here extra. Okay. So if I add a extra T here, so my all values was 0. Okay, I was having one here, one here, one here, one here. This is suffix array. So if I add this t here, all values should be incremented by one, right? I will not be modifying array, but just while accessing the values, I will be doing a plus. Okay, I hope you got it why we are doing plus one here and plus one here. Okay, super. So what is my plan three? My plan three is to just add c and where prefix and suffix is maximum. Okay, so I will be keeping track of maximum value. Maxi will be equal to 0 initially, and I will just, for now I will just increment prefix of I plus 1 into suffix of I, and in last I will double the value which is maximum. Okay, so like outside of this if condition, my maxi will be max of maxi comma p3. Why? So I will be just keeping track of the maximum value. Okay, so I have not added L here, so I have not incremented plus one here. I have not added T here, so I have not incremented plus T here. What I am doing, I am just keeping track of these values, these values, these values, these values. Which value is giving me max? So that's what I'm calculating here. Maxi value I am storing here, and in last I will be just returning. So I need to do one thing. So plan 3 equal to plan 3 plus maxi, and in last I need to return max of either plan 1, plan 2 or plan 3, because that will definitely work. I hope you got it why we are doing all these things. Let's try to quickly write the code for it. So I will write the prefix array something like this. Prefix array will look like initialize with 0 with all, and the n will be length of s. Suffix will be 0 into n plus 1 again. Okay, in any part if you have doubt, so C++, Java and JavaScript code is in description. You can follow me along with that. And if you have any doubt in any part, you can copy this. You can right click the video, okay, and copy link at the current timing, paste it, and that way you can ask the doubt at any specific point in the video. Okay, so fill prefix table for I in range. I'll be starting from 0. I'll be going till n minus 1, so I have to write n here. What I need to do, prefix if s of I equal to L, then I need to make the I plus 1 as 1, and in last I plus 1 will take up the value of prefix of I. I hope this part is clear. We have discussed in detail fill suffix table. So for I in range, what I need to do, I need to go from last till 0. Okay. So if s of I equal to t, then I need to worry about this suffix table. And suffix of I will be 1. And in last, I need to increment suffix of I will take up the value of the last value of the suffix. Super. We have filled the prefix and suffix table. Now my plan 1 equal to 0. Plan 2 equal to 0, plan 3 equal to 0, and maxi will keep track of the maximum values. Okay, now let's start. For I in range n, if s of I equal to c. Super. If it is c, I can I add if I have added l here in the beginning if I have added l here, what answer I can get? So p1 equal to prefix of I plus 1. Okay, so this will be the answer when I have added L in the beginning. So this will be my number of count of L in the left side into how many T's are there on the right side. So this will be in suffix of I. What will be my plan 2? Plan 2 is key add L in front. add p in last, add c in optimal place. Super. Okay, find max optimal value of c. Okay, so my plan 2 will be suffix of I, whatever suffix value. So I have added t in the last, so all my value will be incremented by 1 into prefix of I. Simple. What is my plan 3? My plan 3 is I will just double one value, wherever I am getting maximum, I will just double that value and I will see that is giving me any benefit or not. So I plus 1 into suffix of I. Okay, now maxi I will be keep incrementing every time maxi equal to prefix into suffix, right? And last, I can in plan 3 I can increment my maxi and I can return max value of plan 1, plan 2 and plan 3. Okay, I hope you got it. Let's try to run this and see whether it's working fine or not. Okay, we are getting some wrong answers. Let's check why. Okay, so we did two mistakes here. First of all, this should be prefix of I plus 1 because this prefix of I plus 1 will be the correct index. And I forgot to add a plus here in every place. I think, yes. Let's try to run this and see whether it's working fine or not. Okay, it is working fine. Let's see to submit and see whether it's working fine. Okay, it is working well. So I hope I am able to explain you this question, and if you have any doubt, please feel free to comment down. And if you learned something new in this video, please make sure you subscribe the channel and like the video. It will not take any effort from you, but it will definitely motivate me to make more such videos. So thank you very much guys for watching this video, and we'll meet in the next one. Thank you.